Yes, good evening, class. So, I would like to continue with my last discussion so far. During our last meeting, wherein we had several problems running the program. But if you're going to think of it, I was trying to analyze also what I am doing back then, and it seems that I have a minor mishap performing the condition when a specific value has been met already. Instead of using while, I'm forcing it to use if. Now let me explain to you that mistake clearly. Okay? So let's now try to go back again to the shared object that we have. Okay. Now, I made the shared object as simple as possible. There are some few changes that I've made. So anyway, previously this is public, so I just made it as private. And I have here, since this is private, I have here an accessor method which simply returns the value of x. Now, as what you can see, we have here an increment operation. What it does is it simply prints out the value of x and increments the value of x by 1. And of course, the decrement is the opposite. Now, moving forward, what we wanted to do is that somehow we wanted to emulate the producer and consumer problem. Okay, so for a certain producer, we wanted to make sure that it doesn't produce infinitely, or it doesn't produce uh, values, okay, greater than the maximum of 100,000. So think of this as our container. We do not want the producer to reach more than the value of 100,000. Of course, for the producer, this is represented by add. Okay. Now for the consumer part, and it is represented by the minus thread that we have. We do not want our storage, okay, that even if it's zero already, it will continuously decrement, okay, the values inside it. So somehow we might want to put a control on how they are actually working with one another. So look at our main driver.java here, okay? So I actually created three producer threads. Okay, so let me uh, put it this way: producer, producer, and then producer. Of course, we have one consumer thread. So in other words, if we are going to demonstrate uh, it graphically, here is the shared object, okay? And we have actually three or four threads that are actually working, okay? So we have three producers, okay? So we have three producers represented by the add class, and then we have one consumer that we have also activated, and all of them are actually operating on the value of x. Okay, so that is what we are actually modifying, the value of x. Now, of course, we do not want the producer to increment further x if it reaches 100,000. Okay, and of course, we do not want to decrement x also continuously if it has the value of 0, and that is actually our target. So going back to the program, okay, if you can still remember, we can now work on the add thread, okay? So on the shared object thread. Now for the shared object thread, of course, we can now make a condition here. Previously, we have written it this way: if x is greater than or equal to the main driver, okay, that max, no? we are actually executing the wait statement. There you go. Okay. However, of course, this would throw an interrupted exception. I'm sorry. So we will just have to surround it with a try and catch and just replace this with a system.out interrupted. Okay. So here is what went wrong. Since this is actually a thread, okay, once it indicated or evaluated this expression as false, it would still continue to this statement. So if you can still remember, we have notify all just below x plus plus. So no matter how we try, the thread will always execute notify all. And that's the only problem that we had last time. Okay, our logic is correct. It's just that instead of using if, we should have used the while statement so that the thread will not proceed to this part of the code. Did you get that idea? And that's the only thing that we missed. Okay? So anyway, what we wanted here is if x is greater than, we have detected that x is greater than or equal to the maximum value of 100,000, the thread would actually wait. Okay? And of course, going to the decrement part, since they are the same, and I'll just have to copy and paste the logic here. Instead of greater than or equal, we have less than or equal to 0. The container is now empty. Okay. Then, of course, we'll just have to wait. Now, maybe what we can do here is we could add more messages like the container is full. So actually, we have to wait. Okay. And maybe what we can do here is container is empty. That's why we wanted to stop. So let me run this program. Okay, so I forgot. Yeah. So what will happen here is that, of course, since we have three producers, it is obvious that we would reach 100,000 first. Okay, and all of them would be waiting. Now, once all of them are waiting, the producer will there's no working producer anymore because all of them are waiting already. Now the next thing here is that the decrement operation would actually still continue until such time that it detected that it does not have any value to decrement anymore, so it has to wait. So to simulate this program, we would be able to reach to a point wherein the program will actually halt because no one is producing and no one is consuming also the values for our variable x. So let's now try the program. Okay, so here is the output. That's what you can see. The producer is actually winning on this part. Okay, and as what you can see, we have here the container is full. However, what actually happened to the decrement part? So we have here the decrement part if x while x less than or equal to 0, container is empty. Yeah. Oh, I see. All right. Since we are on the synchronized method, I'm sorry. Uh, the consumer was not able to enter on the decrement stage. It's because it has been locked already. Remember, if one method has been used by a thread which is synchronized, all of the threads with synchronized method would be locked also. So anyway, uh, maybe if what we could do just to uh, let you see that actually this is working, maybe I could remove the synchronized keyword here and let me run the program again. Okay, see, so we cannot do it anymore. Yeah, there's some errors along the way, and yeah, container is full. Yeah, we cannot. So it's inevitable, class, when we're working with the wait and notify, that we have the synchronized uh, keyword here, and we could now notify all, so that once we have detected that we have added already on the container, threads can wake up already, and they can continue with the operation. So uh, let let me put notify all and run the program. So as what you can see right now, the program is actually incrementing. Okay, it's now slower because the minus part is working. Notice uh, can that we can already control once the container is full. Yeah, it never reaches, or the value does not reach more than 100,000 anymore. Okay. However, since we have three producers, okay, uh, most of the time the values would still be high. Okay, so let me just demonstrate again. Um, let's now try to create, okay, more two consumers with high priority. Maybe this could even out the operation a little bit. So we have 2, and then we have decrement 2, and then we have 2. So we have 2 consumer operation with highest priority and 3 producers with normal priority. Okay, so I'll be running the program, and as what you can see, that our program is running perfectly. Okay, so since there are 2 consumers, the value of X is difficult now to reach the value of 100,000. So what happens if we have 3 consumer we have 3 consumer operation with highest priority? Most probably we would reach to a state wherein the container is empty. Okay, because the 3 producers here are actually are of normal priority, and we have 3 consumers which is of highest priority. So I guess most probably we would reach the point wherein we could empty the container. So let's now look at the output. Yeah, see? Were you able to see that message? Hold on, hold on. Let me look for that. Where the where actually the container is empty. I think I saw something. We were able, yeah, yeah, that one. The message is too fast actually. Yeah, container is. Let me stop the program. So let's check. Let's find empty. Let's find the word empty. There you go. We have we have reached to a point where the container is empty. All right, but as what you can see, we were able to control the situation, and uh, it never we the value never has a negative value inside it. Okay, so again, just to summarize what we have done, through wait and notify, we were able to control how thread behaves and communicates with one another. Okay, so in our increment method, while x is greater than the value, which is that max, we would just ask for the thread to wait. So this thread is actually on the waiting state. So of course, who will wake up the waiting threads that we have? Of course, we have the consumer, all right, since it's actually not less than or equal to zero. You have here a decrement operation and a notify all, notifying the producers that they can add or increment again uh, on the variable x, and vice versa also. All right. So I guess this is more clear to you. So the only thing that the only reason why the program was not working last time is that my condition here is actually wrong. Instead of if, I'm sorry, instead of while, I was I just used if. Okay, wherein it would simply ignore the expression. If it's true or false, it would still proceed with this statement. Okay, so let me just upload this in your Canvas account.